In a previous video, we introduced ourselves to the idea of bonds between atoms, and we talked about the types of bonds: ionic, covalent, and metallic. In this video, we're going to dig a little bit deeper and talk about the types of bonds that are likely to be formed between different elements. And to understand that, I'm going to introduce a broad classification of the elements. And in general, we're just going to think about things as metals and as non-metals. So before I even point out on the periodic table of elements what are the metals and what are the non-metals, and maybe what are the ones that are in between, what are the properties of metals? Well, generally speaking, they conduct electricity. Conduct electricity. They tend to be malleable, which is just a fancy way of saying that you can bend them without breaking. And generally speaking, and there's exceptions to this, they are solid at room temperature. So I'll say solid at room temperature. Now, what do you think the properties of nonmetals are going to be? Well, generally speaking, they're going to be the opposite of this. Nonmetals, generally speaking, at room temperature are often not solid. They're oftentimes gases. They are not going to conduct electricity well. Now, when you look at a periodic table of elements, how do you divide the metals from the nonmetals? Well, that's what this little scratchy yellow line I'm drawing is trying to indicate. So everything above and to the right of this yellow line is a nonmetal. And if you look at the color code from the folks who made this periodic table of elements, everything in this yellow color that we have here, so hydrogen and carbon and nitrogen and oxygen and fluorine, chlorine, I could keep going, these are all nonmetals. And it is the case that generally speaking, at room temperature, they will be in a gas form and they will not conduct electricity well. These things in blue we've talked about in other videos. These are the noble gases. So these are also nonmetals. The people who made this periodic table of elements put them in their own color because you could view them as a subclass of nonmetals. And they tend to be very inert. They don't interact with other things. They don't tend to form any of these bonds. Now, everything else you can consider in some form to be a metal. And the reason why this periodic table of elements has different colors is that there's sub-classifications of the metals. But generally speaking, all of these things that you see right over here below this scratchy yellow line have the properties, generally speaking, of conducting electricity, being malleable, being solid at room temperature. And these things that straddle this yellow line right over here, these things that are in this kind of bluish green kind of color, these are sometimes viewed as metalloids because they have some properties of metals and some properties of nonmetals. But generally speaking, if you know whether the things reacting are metals or nonmetals, you can oftentimes predict what type of bond is going to form. So for example, if I have a bond between a metal and a nonmetal, what type of bond do you think is going to form? Well, when you bond between a metal and a nonmetal, and we saw an example of that in that first video on bonding, say a metal like sodium and then a nonmetal like chlorine, we saw that that chlorine will swipe an electron, the sodium might lose one, then the chlorine atom becomes a chloride anion, and then the sodium atom becomes a sodium cation, and then they become attracted to each other, and then you form an ionic bond. So this tends to form ionic bonds. Now, what if you were to have a nonmetal with a nonmetal? Nonmetal times 2. So two nonmetals bound, I'm having trouble saying it, two nonmetals bonding to each other. What do you think is going to happen? Well, we saw that as an example in that first video where we said, well, what happens if oxygen bonds to oxygen? Well, we saw that was a covalent bond, and that is generally the case. When you have two nonmetals form bonds, it is covalent. And then last but not least, and this might be the most obvious one of them all, what do you think happens when you have two metals forming a bond? Well, you can imagine that will be a metallic bond. where they contribute electrons to this kind of sea of electrons, and that's what makes them conduct electricity so well and malleable. So I'll leave you there. There are exceptions to everything I just talked about, but generally speaking, these notions will serve you well, especially in an introductory chemistry class.